Welcome to Eagles Edu Concepts. In this session, we are looking at the IGCSE and ECZ secondary level chemistry, and we are doing an introduction to organic chemistry. Now, organic chemistry is a very important component of chemistry at each level, and even in your examinations, both in the IGCSE curriculum and ECZ curriculum, these questions, they never miss in either the multiple choice or the theory or the structured questions. Organic chemistry has got a lot of marks in the exam, and it's a must that will always appear in the exam. So pay attention as we start this series. It is a very long topic, but try and follow through. If you're visiting our channel for the first time, make sure you click on the subscribe button and click on that bell notification so that when we post a lesson on this one, is going to help you in your exams. All right, let's have a look at how the introduction to organic chemistry looks like. So by the end of this video, you should be able to define organic chemistry. You should be able to know what a homologous series is. You should be also able to define the terms hydrocarbons and functional groups. Finally, you will be able to know how to test for unsaturation and saturation. First and foremost, let's define organic chemistry. Organic chemistry is the study of carbon-containing compounds, except carbonates, carbon monoxide, carbon dioxide, carbon disulfide, and etc., etc. In short, organic compounds are compounds that contain carbon atoms in them. We are saying organic compounds are compounds that contain carbon atoms in them. There are several examples of organic compounds in life. Talk about things like paper, which is made up of cellulose, and there is carbon in it. Talk of nail polish. So here we have nail polish. Talk of candle, that is there is carbon in candle. Talk about gasoline. It's a mixture of carbon-containing compounds. Talk about some soaps. Talk about some fabric that we use to wear as clothes and making other things. Talk about our very own DNA, deoxyribonucleic acid. Talk about the membrane. And also you can talk about things like ethanol. Ethanol is a widely used solvent. All right, let's look at what a homologous series is. So we are saying a homologous series is a family of similar organic compounds. Each member in a family is called a homolog. In the IGCSE curriculum and ECZ curriculum, these are the families that we are interested in. So we have the alkanes, we have the alkenes, we have the alkynes, we have the alcohols, we have the carboxylic acids, also known as alkanoic acids, and we have the esters. The alkynes, we're just going to mention them and their general formula, and that's it, we are done. These other families, we are going to look at them in details. Let's look at some characteristics of a homologous series. Members in the family shows a gradual change in physical properties as number of carbon atoms increases. Members in the family have similar methods of preparation. What does this mean? We are saying as you are increasing the number of carbons, the physical properties, they also show a gradual change. For example, when you look at this one, it has only one carbon, and you go here 2 carbons, 3 carbons, 4 carbons, and everything here is the same. So in here, the carbons are increasing. This is one family. The next family also, the carbons are increasing. The other family, and so on and so forth. But what physical properties are we talking about? Remember, physical properties are properties that can be detected by any of our 5 senses. And here we are talking about things like melting point and boiling point. So we are saying the melting point and boiling point increases as you increase the number of what? Carbons. Then also the density increases as you increase the number of what? Carbons. That's what it means. Secondly, members in the family have similar chemical properties because they have the same functional group. Members in the family can be represented by the general molecular formula. Let's have a look at what we are talking about. So this is the family. The alkanes or alkanes molecular formula can be determined by substituting for a number here where there's n, we put a number. All of them, we can use this formula. That's what it means when we say same general formula. Talk about the alkenes, also this is their general formula. Talk about the alcohols, this is their general formula. The carboxylic acids, this is their general formula. So all these formulas, they are used to determine the molecular formula. And also we say they have the same functional group. So functional groups, these are the ones here. We'll comment on them later on. Another character of a homologous series is that each member in the family differs to the next by CH2 or by 14. Now 14 simply means the molecular mass. Let's look at the family of alkanes. The simplest alkane is CH4. The next one is C2H4. So here, the difference between CH2 and C is C, and then H6 minus H4, that is H2, and we have our CH2. Again, if you check here, 8 minus 6, H8 minus H6 will give us H2. C3 minus C2 will give us C, and that is the CH2. Also here, 10 minus 8, that is the 2 there, and the 4 minus 3, that is the 1 there. Same applies to this one and that one. That is what that point is trying to emphasize on. How about the 14? You can add, if you add 12 plus 4, this one is going to give us, so this is 12, carbon has got a mass number of 12, hydrogen has got a mass number of 1, so 1 times 4 will be 4, so 12 plus 4, that is 16. You go to this one here, this one is going to be 12 times 2, which is 24, 24 plus 6, that is 30. So 30 minus 16, the answer is 14. Also, you do the same to these ones, you're going to find that it will be giving you the same difference. That's what it means. So just find the relative molecular mass of this one, relative molecular mass of this one, relative molecular mass of this one, and that one. You find that when you subtract for this and that, the answer will be 14. This and that, the answer will be 14. That and that will be 14. So all this is just to explain the point which says each member in the family differs to the next by CH2 or by 14. Let's define a functional group as earlier cited. A functional group is an atom or a group of atoms which determines the chemical properties of organic compounds. So alkanes, they have their own functional group, which is carbon-carbon single bond. Alkenes, they have their own functional group, which is the carbon-carbon double bond. So alkenes, they behave the way they behave because of these carbon-carbon double bond. Alcohols, they behave the way they behave because of this functional group, the OH, which is called the hydroxyl group. Then carboxylic acids, they behave the way they behave because of the COOH, which is the carboxy group. Let's define hydrocarbon. A hydrocarbon is an organic compound which consists of the elements carbon and hydrogen only. There are two classes of hydrocarbons, as can be seen here. So we have what we call the saturated hydrocarbons and unsaturated hydrocarbons. Saturated hydrocarbons are also called alkanes, okay? Then unsaturated hydrocarbons, an example is alkenes and alkynes. Facts about carbon and hydrogen. Before we understand what hydrocarbons are, let's look at facts about carbon and hydrogen. Facts: carbon has got a valence of 4 and the electronic structure can be as shown. So this is 2 plus the 4, which is 6. So carbon is 12C6. And when you write the electronic configuration, this is what you come up with. So the valence of carbon is 4, which means it needs 4 more electrons in order for it to be stable. Hence, it is called a tetravalent atom. Hydrogen only has 1 electron in its outermost shell. So hydrocarbons, we say they are composed of carbon and hydrogen. So it's carbon and hydrogen that are bonded. So since hydrogen has got 1, then carbon has got 4, and then it needs 4 more. So this one will join there, then another carbon there. So you need 4 hydrogens in order to fully bond here. In order for these to bond and be stable, they need 4 hydrogens as shown. So this electron dot, the dot and cross diagram for this molecule here, this dot is coming from carbon, also this one from carbon. So this is 1, 2, 3, 4. Then the hydrogen is coming with the cross. So this hydrogen there, that hydrogen there. When you count, this one will be 2, 4, 6, 8. So the carbon is stable. And the hydrogen here, which only needs 2, it's also stable. So that is how you can represent it. Now, please note, as we are dealing with organic chemistry, it is important to note that hydrogen, 2 electrons, they are equivalent to 1 bond. 2 electrons are equivalent to a bond. So this can also be represented loosely. This is the electron dot diagram. It can be represented like this or like this. Now, since we have said these electrons here, it represents a bond, and a bond is just more like a dash, a hyphen, or anything you can call it. Okay, so this is what I mean. And when you're writing a structural formula, these electrons, you write them as a bond. So this line represents a bond. So when you see 1 line, it means there are 2 electrons. If you see 2 lines, it means there are 4 electrons, because 2 electrons are equivalent to 1 line. So these electrons are equivalent to that one. These electrons here, they are equivalent to where? That one. These electrons, they are also equivalent to that one, and so on and so forth. So it can be represented like that. So this is some facts about carbon and hydrogen. Please remember, we are saying 2 electrons are equivalent to a bond, and a bond is represented by a dash like this. It can face in either direction as long as it's a dash or a hyphen or whatever you might call it, but this is what it should be. So saturated hydrocarbons, what are they? Saturated hydrocarbons are hydrocarbons which contain single bonds only, resulting in the maximum number of hydrogen atoms in the molecule. So saturated hydrocarbons are hydrocarbons which contain single bonds only, resulting in the maximum number of hydrogen atoms in the molecule. For example, we have this saturated hydrocarbon, meaning all the bonds here are opened up. It means the carbon is bonded. All the bonds of the carbon are used up. So you can see the maximum number of hydrogens on each carbon. On the outer carbons, we have 1, 2, 3. So all the bonds are used up. This one, that one, that one, that one. Remember, a carbon is supposed to have 4 bonds around it. So all the bonds are used up here, and they are single. All right, so single bonds, saturated hydrocarbons. Now, that's what we are talking about. There is maximum number of hydrogens in saturated hydrocarbons. How about unsaturated hydrocarbons? These are hydrocarbons which contain carbon-carbon double or triple bonds. So unsaturated hydrocarbons, these are hydrocarbons that contain carbon-carbon double or triple bonds. So we are just going to deal with the one with the double bond because our syllabus covers much of the double bonds. So as you can see here, this is a carbon. There is a carbon-carbon double bond. So it can have 1 or more double bonds. So here we just have 1 double bond. So notice that this carbon here, it is bonded. It only has 1, 2, but you count also these lines as 1, 2. So it has 1, 2, 3, 4. So this carbon has got 4 bonds around it. Then this one here, now the carbons in the far end, the maximum number of hydrogen is supposed to have is 3. Then also here 3. Here it has 3 quite right. But this one here, it can't have 3 because of this double bond here. So one hydrogen is missing. Then these in between carbons, they are supposed to have 2 hydrogens each. So as you can see, this one is only bonded to 1. It doesn't have the other one because it's not possible. If you put another one here, it means you're going to have 1, 2, 3, 4, 5. So carbon can only have a maximum of 5 bonds around. So this is 4 bonds rather. 1, 2, 3, 4. Please note 4 bonds. It can't have 5. That's why the other hydrogen has not been put here, because it cannot be possible to have 5. So what are we saying? Unsaturated hydrocarbons, addition of a double bond reduces the number of hydrogens by 2. So 2 hydrogens are missing here. So like I said from the previous example, 2 electrons, they represent a single bond. So 2 electrons, so this electron, single bond, also this single bond. This is how come 1, 2, because we have 1, 2, 3, 4 electrons. And please let's take note of that. All right, we can proceed. How do we test for unsaturation? How do we test for unsaturation? So we can test for unsaturation using aqueous bromine. So aqueous bromine is also known as bromine water. Aqueous bromine is also known as bromine water. So bromine will react with an unsaturated compound. Okay, so when it reacts with an unsaturated compound, the reddish brown color of bromine, it becomes colorless. In other ways, we can say it decolorizes. Okay, the reddish brown color of bromine decolonizes when you react it with an unsaturated compound. So this is what is happening here. As you can see, this is bromine, reddish brown. You add the unsaturated compound there, and then this is the color initially, but afterwards you notice that after the reaction, this is what is going to happen. See, remains clear. So the result is that it decolorizes what? Bromine water, which is also known as bromine water. So that is test number 1. We also have test number 2, where we can use potassium permanganate, also known as Bayer's test. Okay, Bayer's test. So using potassium permanganate. Potassium permanganate is purple in color. So when you mix it with an unsaturated compound, it also somehow loses its color. But what you're going to notice is, if the compound that you have mixed with potassium permanganate is not an unsaturated compound, then it will remain purple, which is the color of potassium permanganate. But if it is an unsaturated compound, then we are going to have a brown sludge. Okay, so the potassium permanganate reacts with an unsaturated compound to form a brown sludge at the bottom of the test tube. So this is how you know. So this one here, it shows a positive test. This one here shows a negative test. Thank you so much for following this introduction to organic chemistry at secondary level, following the IGCSE and ECZ curriculum.